Have you ever observed this?
Yes, it is the famous device called Newton's Cradle. This device works on the principle the conservation of momentum and the conservation of energy. When a stationary ball on one end is pulled away and then released, it strikes the next stationary ball. But the second ball remains motionless and strikes the third ball. The third ball also remains at rest, but the ball on the opposite end of the row is thrown into the air, then swings back to strike the other balls, repeating this whole thing in reverse order. When the first ball of Newton's cradle collides with the second, the first ball stops, but its momentum is not lost, just transferred to the second ball. Then the third, then the fourth, until it reaches the very last ball. The last ball swings into the air with nearly the same momentum as the first ball. Thus, if two balls are lifted into the air on one end of the device and released, then two balls on the opposite end will swing in response. So, this is how it works based on the principle, the conservation of momentum. But how is it related with the conservation of energy? As the first ball is pulled away, it gains some potential energy at that height. When it is released, the potential energy starts to convert into kinetic energy, and when it stops after striking the second ball, it transfers all its energy to the next ball in the form of momentum. But the second ball does not gain enough energy to move with the other balls. So it just transfers the whole of its energy to the next ball and remains motionless. In this way, the energy passes on the next ball and the last ball swings with this energy and reaches the same height as the first ball. In this way, the total energy remains conserved throughout the whole cycle.